So, all right, so we are starting with function notation and evaluation. So what do you guys remember about what a function is? F of x? Okay. What does f of x mean? Brett? Okay, this is the same thing as a y value. What else do we remember? All right, what about input, outputs? What do you remember? So we use it to solve equations for a graph. When it comes to science, all right, remember we have like our x and y table, yes? Some different vocab you'll see for x and y. X would be your independent variable. Y is your dependent variable. All right. X is also, you're looking at your domain. And domain is what x values work for this function. Y is range. That's not an R. That's not an A. Okay. Do we remember the vertical line test? Yes, no? All right. So I'll refresh your guys' memory on all that jazz. All right, but vocab-wise, these are the two you typically see the most of. All right, independent, dependent variables, and then x and y, and then domain and range. All right. So, if you're trying to determine, well, I guess we should define a function up here as well. I thought I had space for it. So, the actual definition of a function is that for each x value, there is only one distinct y value. Okay. Do we kind of remember that definition? All right. So if you are given a table, XY chart, what are you looking for? So let's just do a random XY chart. All right, so if you're doing this in your notes, I would put, like, when you have a table, and then I would draw the little table out. And if you have, like, colored pens, I always recommend using colors because that makes life a lot easier. All right, so does it matter that for these 2 points, I have the same y value? No. I can have the same y value and still be okay. All right, so the example I use on this is, all right, your oven. Think of a function like an oven, right? An oven does something. It cooks food. So if I put a turkey as a 1 into the oven, I should get out a cooked turkey, right? If I put a batch of cookies in the oven, I should get out a batch of cooked cookies, right? However, and here's your little problem, if I put a turkey in the oven and I get a salad out right here, that ain't right, is it? Okay, I can get burnt whatever it is, that could be the same for, but if I suddenly put a turkey in the oven and out the other side I get ice cream, we have an issue. Okay, this is plugging in the same thing to the oven and getting different results out the other end. Okay, so same y value is okay. If it's same x, but different y's, now we have a problem. Why is this thing so slow today? This is when we don't have a function. And you will see me abbreviate function as FCN. That's because I start running out of room. All right. So would that still apply if we had points? Yeah, because the points are just the same data points on a table. Okay. What about a graph? Nothing else really changes. So the easiest way to do stuff on a graph is using what's called the vertical line test. Okay? So we're going to use and if you want, we can sketch a little graph in here. So if you have a little graph like that, real quick, what's vertical? Hold up your pencil in a vertical fashion. All right, so we know vertical. Cool. Vertical means you hold it up and down, okay? And we're going to drag it across our graph. So I'm going to make a little line in green. All right. This is my vertical line. See how it hits my graph in two places? All right. This could be an x equals 2, but I would have a positive y value up here, and I would have a negative y value down here. All right. So that is no longer a function. Vertical line. All right, and when it comes to equations, the biggest thing we're going to look for is if it's got a y squared, it is probably not a function. If it's got a y squared, that's going to be your sideways parabolas. That's going to be a circle. All right, all things that would naturally fail the vertical line test. When in doubt, use Desmos and type in the function and get a look at it. Because in theory, you guys haven't seen a whole lot of different styles of functions. So it helps when you can see it a little better. Can I scroll a little bit? Yes, no, maybe. What's up? I heard an Mm-hmm. On. Yes. So what that means is, like if we look at our little graph, the question was, I'm kind of confused about the wording. So vertical line, see how I drag it across and I hit my blue graph twice? That means for the same x value right here, I have a positive y and I have a negative y. All right, so that's putting a turkey in the oven. You get a cooked turkey up here. You get a salad down here. That's our issue, right? I don't know why. The food example has worked for like the last 10 years, so I kept it. All right, so function notation. You've got f of x, so a function of x. All right. This part right here is your independent. And then the whole shebang is your dependent. If I tell you f of 3, you are going to plug in x equals 3 and see what it spits out. All right, if I give you f of x equals 7, you're going to replace f of x with the 7 and solve for x. Ready? So when you're evaluating a function algebraically, you want to ask yourself, do I have the x value or do I have the y value? Okay? So remember, having the x value is f of 2. Having the y value is f of x equals 7, or whatever it is. Okay? And then the biggest thing is once you know what you've got, then you can go through and actually solve. So I have 4 different examples up here. Which ones do we want to do? Do we want to do all 4 or do we want to just do a couple? You guys tell me. I pick? All right. If it's me, I'm going to go with probably A and C. All right. So we'll go A and we'll do C. So for A, what do I have? The x value or the y value? Michael? X value. So this is x. What I'm going to do is I'm going to take 3, plug in -2, and add 1. So I've got -6 plus 1. That gives me -5. So that means f of -2 equals -5. Now, common mistake here that kids will make is they will try dividing out by a -2. Nope. Leave it alone. All right? This is giving you the coordinate of -2, -5. Okay? It's telling you, if you plug in -2, where am I going to end up on the graph? All right, so do not try to divide out by a -2. It's giving you information. All right, so we're going to use that same function for C. On C, though, what am I given? The y. So, remember, my function was f of x equals 3x plus 1. All right, I am going to replace this f of x right here with the -2. So So now my goal is to solve for x. Move my 1, and I've got negative 3 equals 3x. Divide both sides by 3, and I get negative 1 for x. So if you want to get in the habit of writing it like a coordinate because you're kind of afraid you're going to try and start doing funky things with it, you can. Or you could just say x is negative 1. Which one would you guys rather do, E or F? Which one looks a little bit more terrifying? E. All right, so still using the same function, where f of x equals 3x plus 1. You don't have to keep writing it like on a worksheet. You would have it and be able to see what you're doing. I just keep rewriting it because mine's 4 feet up into the ceiling. All right. So what's it telling me to replace? The x value or the y value? You're literally just going 3 times t squared plus 1. That's it. You're done. All you've done is you've plugged in t squared for an x value. All right, substitution. That's it. All right, if you want to rewrite it, you can. You could leave it like this. Why is my phone going off? All right, both of those are acceptable forms. All right, so far so good? Now, if you were to do f and you plugged it in, you would actually need to keep simplifying it. I can't keep going with this, right? But on f, I could plug that whole quantity in for x and then solve for it, all right, or simplify that equation down. All right, do we want to do any more of these, or are we okay with just that one example? Because I have a whole second set. Thumbs up, thumbs down. We're good? I got 2 votes for we're good. Everybody else is just staring at me. Another y value? Yeah. So write down this example, because this one's going to be a little messy. And we'll do a y value with it. Mm-hmm. He's stuck. Hang on. All right, so do you guys see B? B's a y value, correct? What kind of lead do you need? 0.09, 0.7, I have 0.09 and I have 0.05 and I have no 0.7. All right, you ready? On this one, I'm going to go, okay, fine. 5 equals x squared plus 3x minus 4. Now, the big thing when it's coming to quadratics is I'm going to be a little bit of a jerk and try to get you to remember how to factor from Algebra 1. Okay? You guys remember how to factor or no? Yeah, some teachers teach you with the X or the box, or some teachers call it headbutt gut, or whatever nonsense that is. All right, I just teach like factoring by grouping because that is headbutt gut, and because if you say headbutt gut to a college professor, they are going to laugh at you and be like, what kind of nonsense is that? So your first step on these is always to get it so it equals 0. All right, so I need to move that 5 over. So I've got 0 equals x squared plus 3x minus 9. And this is easier right now like that one right there, if you were going to factor it, you need multiples of 9 that gets you to 3. All right, so it's 3 and 3 make 9, or it's 9 and 1. The problem is none of those are going to get me to 3 in the middle. So that means the answers I'm looking for are a little nasty. So I would graph it with Desmos. Or you could use the quadratic formula. You guys remember the quadratic formula? Yeah, it's negative b plus or minus square root. Yep, divided by 2a. That thingy. Yep. Oh, it's b squared minus 4ac. Yeah, I got the order wrong because everyone was shouting 4ac. All right, but these only come secondary to after attempting to factor. All right. And if I'm going to give you one on a test where you have to factor, I'm going to make sure it's nice. All right, but I also want you guys to get used to recognizing, okay, this is going to suck to factor, do not want. Go quadratic formula. All right, we're almost done, I promise. Have we ever seen something like that? Yes? What is that? It's called a piecewise function. Okay? So a piecewise function says that f of x has 2 parts. All right? So for every x less than negative 2, I'm going to use the function 3x plus 1. For every x greater than or equal to negative 2, I'm going to use 2x squared minus 4. All right? So I would make sure you have this part written down. It's called piecewise. And don't worry, we're playing with this more later. Some people have seen it, some people haven't. While you guys are writing this, I'm going to come around with a piece of double stick tape. I would flip over to a page where you've got enough room to paste in the graphs that I gave you. I didn't give that row graphs. Sorry. All right, so write down the 3 examples that you see underneath. And we'll glue these graphs into your notes here in a minute. And by glue, I mean double stick tape. Now, do y'all know how to work double stick tape? Are we sure? Because I had a lot of kids last year that tried treating double stick tape like regular tape, and they couldn't figure out why their notebook, when they closed it, kept getting stuck to the other page. So you use double stick tape like a glue stick. You stick it on the back of whatever you're trying to tape into your notes, and then you just slap it down in your notes. Okay? It's sticky on both sides. They would put it on the edge, on the top, and then like close their notebook, and they're like, my notes keep ripping. And I'm like, it's because it's not regular tape, dude. Yeah, there's silly. All right, so these restrictions, and I'm color coding for a reason. I always look at it first and figure out which function I need to use, okay? So for A, it says f of -4. So is -4 less than -2, or is it greater than or equal to -2? Oh, stupid. Yeah, it's less than. Okay? It is. Right? So if it's less than -2, I'm using my red function, which is 3. Plug in my -4 plus 1. All right? This always helps in figuring out which equation I need to use. So I've got -12. -12 plus 1 gives me -11. For B, I have -2. Which one am I using, red or green? Green. All right. Because it is equal to -2, so I need to make sure I'm plugging it in the right spot. So 2 times -2 squared minus 4. You guys just want to flip your graphs over and put it up close to the top of the table? How about I just stick the tape on the back for you? All right. When you guys go to evaluate that, make sure you're following your order of operations correctly. Okay? So what that means is, when I say use your order of operations correctly, don't try to multiply the 2 times the -2. You actually need to square this first. So what's -2 times -2? 2 times 4 minus 4. 2 times 4 is 8. Minus 4 gets me back to 4. Okay? Lots of 4s. 4 apparently is the number du jour. All right, try C real quick. All right, for this one, which one did we use, red or green? Green. So 2 times 0 squared minus 4. What's 0 squared? What's 2 times 0? Okay, 0 minus 4. Voila. We done. You don't have to write it in coordinate form because I feel like that can sometimes get a little bit more confusing. As long as you circle your answer to make it easy to find, that helps. All right, so we are actually going to start using our lovely little graphs, okay? Hence why I printed them. So yes, Michael cut them off. You didn't lose a finger. Yay! Maybe, if I can get it off my finger. All right, so I did stick it to the floor. I'm sorry. So stick this in your notes, somewhere where you've got enough space to write those examples up. All right, so we're going to start with our absolute value function. $2.20, I don't know. Alex, I know, I'm working on it. I ran out. I was going to say, I wasn't here yesterday afternoon, so I have no idea where that came from. I love colors. When we hit 1.4 notes, you're going to appreciate the colors. All right, so you guys are not getting double stick tape. You're getting regular tape. I already did yours. Well, you get an extra piece. Okay. Scoot it over here because you're going to want the space. All right. I give you guys tape. All right, everybody taped up? All right, so this is what happens when you're given a graph, okay? What I'm going to do is I'm going to look at each of my examples and find where they are. Does it help when I color code them? Okay. You just like using all the colors. Yeah. All right, so A is f is -1. All right. What am I looking for? The x value or the y value? All right. So I've got the x. I'm looking for the y. So I'm going to go over here to -1. And then I'm going to go up on my graph until I find my answer. So it's 3. That's it. Don't overcomplicate it. All right. There were a lot of kids last year that were like, but I don't have the actual equation. I'm like, bro, you have the picture. You can find it. It's like, where's Waldo, but on a graph. All right. B. I have x is 4. 1, 2, 3, 4. Go up. 1, 2, 3, 4, 5, 6, 7. All right. For C, now I've got a y value. All right. So I'm going to have 2 different x values, and that's okay. All right. I'm going to go up for y equals 5. 1, 2, 3, 4, 5. And I've got an answer here, and I've got an answer here. So I've got -3, or I'm sorry, +3 and -2. Do we want to do example D? Okay. You want to try it on your own? Okay. Did you get -3 and 4? Yeah. Easy enough? Don't overcomplicate these. That's all you're trying to do. All right? Now, for our last little example, I just say we do A, B, and C. I'll move this up just a little bit. Do you guys want to try that with your neighbors? All right. Do you guys need a random question of the day? Okay. Huh? I know. Okay, random question of the day. What is the biggest thing that you got in trouble for when you were under the age of 10? And I'll tell you mine. Ohio used to have a SeaWorld. Did y'all know this? Okay, well, there was a SeaWorld in Ohio at one point. I may or may not have walked away from my parents and shut down the entire theme park because a lady shoved in front of me before I went down the slide, and I was a little upset by it. So I decided to go play in another area. So, like, I was the Amber Alert before an Amber Alert. Like, they shut down the whole theme park, would not let people out. Yeah, that did not end well. Oh my God. They just lost their kid. Yeah, they were a little upset.
Were
Yeah. Yeah. No, I wouldn't have gotten in trouble for that. But I probably would have a little, because my mom would have been like, dude, how many times have I had the conversation with you about you don't go with strangers? You blamed it on the Easter Bunny?
Yeah. My parents still make fun of me to this day. Every time I like drop something or like I break something, because I break a lot of dishes and I drop everything. They're like, "Oh, did the Easter Bunny do that?" I was like, "No, we can say it."
All right, we still working on this? Do we think we have answers? All right. Did we get those three? All right. Cool, then we're done. So your homework tonight is the first worksheet out of that packet. So did anybody not get the packet